know last time we met on Zoom and we talked about probability, but I guess it wasn't recorded. You asked me to put it on, but I couldn't find it, unfortunately. That's why I decided to make this lecture. I was gonna do a Zoom conference, but I said, let me put this lecture. You can kind of watch that, and probably this weekend we're gonna have one or a couple. Until Monday we decide what's going on. So this is just the lecture we did last time on Zoom. I think it was a couple of days ago. Just for people who missed it, I'm gonna do this and put it on Canvas. Please watch, and it's a good idea if you can meet this weekend. I'll just send you the invitations for the Zoom, and this time I know how to record it 100%, so it will be recorded for people who missed it. So what we did, we talked about probability. Now probability, what is probability? Probability is chances of something happening. So for example, if I say what's the probability of rain today, what you do, the first thing, you go outside, if you don't listen to the news or you don't have internet, you look at the sky and you look at the clouds, and by experience you can just guess a number. If there are a lot of clouds, you can say 90%. If there are like no clouds, you say 0%. The probabilities that we are going to calculate in this class are, you can calculate it actually, so we don't guess it. There are ways to calculate probabilities. Now in order to talk or to know about probability, there are three definitions. Number one is experiment. Number two is the sample space. And number three is an event. What is an experiment? Any process that involves probability, it's called an experiment. Sample space is the set of all outcomes. I have those definitions for you, so you can read them, but with the examples I'll show you what they are. And an event is a subset of the sample space, and what we do usually, we calculate the probability of an event. Now let's do some examples. Tossing a coin. This is the experiment. What we do, we toss a coin, and tossing a coin involves probability. So let's write the sample space for that. The sample space, all the possible outcomes are heads and tails. Now if I write the events, we have the event of, let's just put H, we can write it like that. And that's, H is a subset of that. So, and we have the event of tail, which is just tail. Just to, I'm going to go over this in detail, but this is called set notation. When you see these curly brackets, so this is set notation. Now we can calculate the probability of this first one. I can just write it P of H. What's the probability that I toss a coin and that's a head? So that's just, we all know it's 1 over 2. How do we get 1 over 2? The number of elements in this set is 1, which is the numerator, and you divide that by the number of elements in the sample space, which is 2. So the probability of head happening is 1 over 2. And same way, if I say P of T is also 1 over 2, which is pretty obvious in this case, but then it's simple, but it works. That's how probability works. Number of elements in the event of tail is 1. That's the numerator. and we divide that by the number of elements in the sample space, which are 2, and you get the probability of tell. Second example we did was rolling a die. So when we roll a die, first of all, let's write the sample space. We know we have 6 faces, that means 6 numbers. So it's 1, 2, 3, 4, 5, and 6. Now if I calculate the probabilities, number 1, if I say what's the probability that 1 happens, or we roll a die and we see 1, so that's 1 over 6. That event has 1 element over 6. Number 2, what's the probability of 1 or 2? Now if I write this, you guys know the answer is going to be 2 over 6. However, it's probability of 1 plus probability of 2, so that's 1 over 6 plus 1 over 6, and that's 2 over 6, which is 1 over 3. Number 3, if I say what's the probability of an odd number, odd numbers, how many odd numbers do we have? 1, 2, 3, so it's going to be 3 out of 6, which is 1 over 2. Number 4, if I say what's the probability of 1 and 2, just be careful, I'm using or, here I'm using and. What's the probability that I roll a die and it shows 1 and 2 at the same time? And of course you can't have that. The probability is 0. That cannot happen, so you say this is the impossible event. So let me, oh, there is one, I can fit it here. Number 5, if I say what's the probability of not 1? Not 1, that means I want all the numbers but 1. So all the numbers, if I hide 1, so we have 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, so it's going to be 5 over 6. So that's another example of probability. Sample space, these are just events when you write it and you calculate the probability. Now, let's see. Let's do some couple of more examples, and I'm going to put the formulas for you as you're getting used to it. Another example is tossing a coin twice. So let's see, if we toss a coin twice, what is the sample space? The sample space is going to be HH, HT, TH, and TT. Head, 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 tail, and tail, head, and tail, tail. These are all the possibilities we can get, or all the outcomes we can get. So, number 1, if I say what's the probability of exactly one tail. Exactly one tail, that means from one of the tosses, I want to have one, I want to see one tail only. So here you can go to the sample space and count those events. So exactly one tail, I can take this because I have one tail, and I can take that, I have one tail. So the answer is 2/4, or it's 1/2. Number 2, what's the probability of at least one tail? At least one tail, that means one or more. So let's see, let's check those events. I can take that, I can take that, and I can take that because I have 1, and this one is 2. So the answer is 3/4. I just want you to know, when you hear at least 1, you can also do 1 minus probability of no tails. Now what is 1 minus probability of no tails? It's 1 minus the event that does not have any tails, and that's 1/4, and the answer is 3/4. Well, let me do it slowly so you can see. 1/1 is 4/4 minus 3 or minus 1/4, and that's going to give you 3/4. Finally, number 3, if I say what's the probability of at most one tail, at most one tail, that means 1 or more. 1 or more, that means one, no, at most one tail, sorry, is 1 or less. So can I take that? Yes, it's 1. Can I take that? Yes, it's 1. Don't forget, you can take that because it's 0. 0 is less than 1. So in this case also, it's going to be 3/4. Then we did an example, and we said that tossing a coin 3 times. If you want to write the sample space for that, so let's go ahead and, if you want to make it easy, you can use the tree and then write the sample space. I think I can erase these two. So let's see, we toss it the first time, we can get HT. We toss it the second time, HT, HT. And we toss it the third time, HT, 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 and HT. First time, second time, and third time. Let's write the sample space. The sample space, you can start from here, is H, 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 T, H, H, T, H, T, H, H, T, H, H, T, T, H, T, T, then we come here, T, H, H, T, H, H, and then we have T, T, H. T, T, H. And finally we have T, T, T. So T, T, T. Let's count. 1, 2, 3, 4, 5, 6, 7, 8. So here we have 8 outcomes. How do you get that number? Whenever you have two possibilities or two categories like heads, tails, true, false, and female, male, when you want to do that, you can just say the number of outcomes in the sample space are calculated by this formula, to the power of n. Here n is 3, so to the power of 3 is going to give you 8. You can get that number. When we tossed it twice, it was to the power of 2, and we had 4. So remember, for twice we had HH, HT, TH, and TT. So this was 2 squared, which is 4. If you toss it 4 times, then it's going to be to the power of 4, which is 16. Now if I calculate some probabilities, number 1, P of exactly 1 tail. Exactly 1 tail, I can take that. 1, 2, 3, and that's it. 1, 2, 3, so it's going to be 3 over 8. Number 2, if I say P of at least 1 tail, so that's going to be at least 1 tail. We have that 1 or more. That 1, 2, I can take that 3, 4, 5, 6, and 7. It's 7 over 8. And please don't forget, probability of at least 1 is the same thing as 1 minus probability of no tails. So it's going to be 1 minus probability of no tails. So let's see how many no tails we have. It's it's 1 over 8, and again this is 8 over 8 minus 1 over 8, 7 over 8, same number. Please remember this, because we're going to have a problem like that on the test. Number 3, P of at most 1 tail. At most 1 tail, that means 1 or less. So let's get those. At most, I can't take that. No. Yes. 1 tail, I can take it. Yes. 2. No. 3 and 4 and 5. Let's count this. 1 or less. 0 tails, I can take it. 2, 3, 4, and that's it. Doesn't fabulous force. It's 4 out of 8, which is 1 half. So that's when we toss a coin 3 times. Again, when I say coin, it could be a test when the questions are true or false, or if you pick from a group, you pick somebody there. If it's female, male, you're gonna do more examples and you're gonna see. Now, since you know, you have an idea of probability. Let me write all the formulas. And we can do more examples. So let me put the formulas here, and I can do some examples and use the formula. What we said the probability of an event is always between 1 and, actually, 0 and 1. Number 2, the probability of the sample space 1. Number 3, P of A or B is the same thing as P of A union B, and that's P of A plus P of B minus P of A intersecting with B. This is the addition formula. That notation is called union, or we call it OR. So this is union. Number 4, P of A or B is P of A union B, and that's just P of A plus P of B. You don't take that part. If A and B are mutually exclusive. Mutually exclusive, we went over this last time, but for people who did not participate, I'll do an example and I'll show you right now. So, number 5, P of A intersecting with B is P of A times P of B if A and B are independent. Now, independent doesn't mean mutually exclusive. I'll tell you what independent is, but just know independent means the probability of one has nothing to do with the probability of the other one, or the probability of one event has nothing to do with the probability of the second event. So we'll do examples. Number 6, P of A given B is P of A intersecting with B over P of B. When you see that line is, you read it given. So that's the formula, and that's called conditional probability. So we'll talk about that. And finally, the last one, P of A complement, or sometimes you see P of A with a line on the top, or P of not A, that's 1 minus P of A. So that's the probability of the complement. These are the formulas we're going to be using. I did one example last time to let me do that. One also, then we can have our Zoom meeting this weekend for sure. Tomorrow we can have it. But the example I did, I talked about sets. So what is a set? Again, when I said sample space is a set. When we talk about event, an event is a set. Now if I take this, let's say 1, 2, 3, 4, 5, 6, 7. That's our sample space, or we call it the universal set. Then we can have some subsets of that. 1A is 1, 2, 3. B is, let's say 3, 4, 5. And C is, I can just put 6. You don't have to put all of them. Now, number 1, A union B. These are the elements in A or in B. This was the same thing as A or B. So these were 1, 2, 3, 4, 5. Number 2, A intersecting are the elements that A and B share. So it's 3. Number 3, A intersecting with C. You look at A, you look at A, see no elements in common. So that's just empty set. Number 4, if I say it's not A or A complement or A with a line on the top, these are the elements that are not in A. So you go to your sample space. A is 1, 2, 3. You take those out. You're left with 4, 5, 6, 7. 4, 5, 6, 7. Now we're going to calculate the probabilities of those. Number 5. What's the probability of A? The probability of A happening is 3 out of 7. Number 6. What's the probability of B? What's the probability that B happens? Is again 1, 2, 3 out of 7. 3 out of 7. Number 7. What's the probability of A union B? Probability of A union B, we have 5 numbers here in this set, so it's 5 out of 7. And I just want you to be careful. We can use this formula. We can say it's probability of A, let me write it, P of A plus P of B minus P of A intersecting with B. Let's see that if that works. P of A, we have it is 3 over 7 plus P of B is 3 over 7 minus P of A intersecting with B. It's right here. That's only one element. 1 over 7. So that's going to be 6 minus 1 is 5 over 7. Same answer. Sometimes it's much better to use the formula. If you see it, you can just put it. If not, you can use the formula. Next, if I say, oh, let's do this one too. Couple of them. I think that's, we're done with the last lecture and we can just do a new one tomorrow. And of course, this is a very bad board and it doesn't erase. Let's see. If I say what is the probability of A union C, that's going to be P of A plus P of C minus P of A intersecting with C. Let's use this formula. P of A is 3 out of 7 plus P of C is 1 over 7 minus P of A intersecting with C. The intersection of A and C is the empty set. The probability of an empty set is always 0. So the answer is 4 over 7. This is what we use. Where is it? P of A plus P of B is just that, because the intersection, there's no intersection, and because here A and C are mutually exclusive. If no element in common, that means the sets are mutually exclusive. And the last one, if I say that was number 7, number 8, number 9, if I say what is P of A complement or P of not A, P of not A, that means the elements that are not in A. So the elements that are not in A in the sample space are 4, 5, 6, 7. So the answer is 4 over 7. Alright guys, I think that's what we did last time. I'm gonna put this on canvas right now. Please watch it 2 or 3 times and try to understand. This is not very hard. And once we connect this weekend, then I'm gonna talk more about probability so we can finish it. Once that's done, we do our calculators, the sample exam, and then we can take the test. Stay safe, have a good one. Thank you.